All right, it's me again. I feel like keep listening to me talk. So like I was mentioned earlier, I'm the product manager at Eclipse. We are Ethereum's first SVM L2. So a little bit of a background about Eclipse, right? What exactly is Eclipse? Before I go into the architecture of Eclipse mainnet, I think it would actually be helpful if I provided some history of Eclipse and give some context as to how we arrived at this architecture. So when Eclipse first started, we were a rollup provider. We had our own rollup framework that utilized the Solana virtual machine. And at one point, we were running dozens of chains, so dozens of app-specific rollups. In doing so, there were two main issues that we found. Number one, most apps it's actually highly uneconomical for most apps to run their own rollup, right? Obviously, there are a few exceptions to this, but for most apps, you just can't amortize the L1 posting cost across many transactions because they're just not getting enough transactions to really warrant that. So instead, it ends up being the user of the app-specific rollup. They end up suffering and having these interop issues. They're not really getting any fee benefits, and so on and so forth. The second big issue that we found is that the thesis that Ethereum scaling roadmap is going to have thousands of rollups is actually a byproduct of the single-threaded EVM. Because a single-threaded EVM can't really handle the scale that's necessary to ultimately scale Ethereum, this is why you need multiple chains running the same single-threaded EVM, and essentially it's like some substitute for a multi-threaded environment for Ethereum. Now, what we found that actually is an SVM general purpose L2 solves a lot of these issues, right? Because the user doesn't have to suffer the interop issues that you get with all these app-specific rollups. You don't get the uneconomical, the economics of running an app-specific rollup. As an app, you don't have to eat that cost. And as a user, the user experience is just significantly better. So you have this wonderful opportunity where each component of the blockchain is decoupled, and we felt like there was kind of a lack of innovation within Ethereum and how the decoupling was being utilized. So we took a step back and essentially decided from first principles, if you were to pick the best pieces of the modular stack, how would you build this blockchain from the ground up? What we ended up with is, for our execution environment, we are leveraging the speed and scalability of the Solana virtual machine, and I will touch more on that later. We are inheriting security properties by settling onto Ethereum. Eclipse mainnet will have ETH as its gas token, which means that as a developer on Eclipse, you get to tap into the liquidity and network effects that ETH has. And for data availability, we are using Celestia because of its high bandwidth and verifiability properties, such as data availability sampling. Try saying that 3 times fast. And lastly, for ZK proofs, we are using Rizero. So why do we pick the SVM? First and foremost, obviously, is performance, and we've already talked a lot about performance in the last panel, so I won't go into too many details, but of course the SVM is parallelized compared to the single-threaded EVM, and it can enable a lot of net new apps that just aren't possible previously within Ethereum ecosystem. The second reason why we picked the SVM is security. So the SVM actually can more easily protect against certain bugs that Solidity does not. So some of the most famous hacks within crypto have been something called a reentrancy attack, and that is something that can't happen on the SVM. The reason is SVM basically only allows programs to self-recurse, so you aren't able to kind of have this reentrancy attack. Ease of use is another consideration of why we picked SVM. Of course, Solidity is easier to code in, but Rust is still a very popular language globally. Provability is another big reason why we picked the SVM. So the SVM is register-based, which means it's easier to prove than EVM. And of course, there are more VMs that are optimized for ZK proving, such as Cairo, or VMs that are completely UTXO-based, such as Fuel VM. Lastly, and a really important reason on why we picked the SVM is the community. So there's a very robust developer community around the SVM already. I think Ethereum and Solana have both done a great job at fostering developer community around the EVM and SVM respectively. And tangibly, that translates to more robust developer tooling for those ecosystems, especially when compared to a newer VM such as Move VM or Fuel VM. To dive into the benefits of parallel execution a little bit. So what exactly is parallel execution? I know this is a term that gets thrown around quite a bit, but in the simplest form, parallel execution just means that multiple transactions can execute at the same time as opposed to one at a time. And theoretically, any VM can be parallelized. So SVM, EVM, anything really. But the difference is that SVM is built from the ground up for parallelization. So the Solana wire format specifies which state is being executed upon. And SVM is the most battle-tested, production-ready VM on the market right now. So of course there are advancements in other VM, but we've already seen kind of the SVM's capabilities live right now. So for end users, parallel execution means a couple things. First, it means fast and cheap transactions. Second one, fee spikes for a single app won't impact the rest of the chain. So the most famous example, of course, is Yuga Labs with their other side mint, where because it was such a hot NFT mint, it rendered the chain useless for all the other applications. And something like that just wouldn't happen on a multi-threaded virtual machine like Solana Virtual Machine. And lastly, like I mentioned earlier, the reduced attack surface area, which prevents these famous exploits that would normally happen on EVM. So how does Eclipse actually compare? We ran a benchmarking. This benchmarking runs about 10 instances of an AMM doing about 275 swaps. And you can run this benchmarking yourself if you just go through our developer docs. You can see kind of how our testnet compares. But what we found is that the average time is about 34 milliseconds per swap, which is significantly faster than any existing L2s. Now, on to the next piece of the architecture. What is Ethereum settlement and why is it important? So I would say this is probably one of the most core pieces of the Eclipse infrastructure. And for us, settling to Ethereum means that our validating bridge is on Ethereum, and fraud proofs will also be submitted to this bridge. And there are a couple other things such as force inclusion via the validating bridge. So that all sounds like a lot of terms. Like, what does that mean exactly? It means that tangibly for the user, you are inheriting certain censorship resistance properties and eventual liveness from Ethereum. So if the L2 sequencer were to censor, a user is able to force include their transaction via the L1. Another reason why it's important is that it does signal our roadmap to maximally use Ethereum. We're constantly looking at how else we can use Ethereum, whether it's moving to Ethereum DA whenever that's a viable option, or perhaps using Ethereum L1 as base sequencing. There's a lot of creative ways that we can be using Ethereum within our architecture, and that's something that we are constantly evaluating. Lastly, and probably one of the most important things, is leveraging Ethereum asset base and users. So how big exactly is this asset base and user base? So if you see here that Ethereum TVL is actually the largest of any chain at $47 billion. And in fact, it's actually higher than all these other chains combined. So as a developer, you're getting access to this robust, asset class and liquidity and network effects that come with being on Ethereum. Now, quickly, how does Eclipse compare? Eclipse compared to Arbitrum or Optimism, as you can see, from a performance standpoint, it's going to be a lot more performant, way higher throughput at a fraction of the cost. And compared to the Solana L1, of course, the performance and the gas costs are going to be somewhat comparable to Solana L1, but the several things that we hold very dear are actually our verifiability properties. So Eclipse will have fraud proofs as well as light node support, which Solana does not. So more simply put, it's the most performant VM using the best internet money. That is a very powerful combination, and we think that this architecture can enable a lot of net new use cases, enable developers to build whatever they would like. That's actually something that I'm personally most excited about, especially as a product person, is great, Eclipse will handle the architecture, but what can you actually build with this highly performant architecture that has the distribution effects of Ethereum? So I have a couple of examples, and first we'll start out with some DeFi ones, the first one being a fully on-chain club. The benefits of a club or a central limit order book is that all the open orders, the prices are a lot more transparent on chain, and you're going to get better liquidity, better prices as a result of using a fully on-chain club. If you actually think about the AMM, the AMM is somewhat of an artifact of the single-threaded EVM, and we actually think that by bringing the SVM to Ethereum, you can enable a lot of more interesting DeFi use cases. So just to take this collab idea a step further, there's an interesting asset class that you could tap into on Ethereum, which is liquid staking tokens. Right? That is a very robust asset class within Ethereum. There's several ways you could utilize it, whether it's leveraging LSTs within the club. You can mint the LSTs from open orders within the club, and that will actually generate some staking yield that can attract market makers. If you want to take it even a step further, you can earn restaking yield through EigenLayer. But of course, it opens up the design space a lot more with the SVM as opposed to just having a single-threaded EVM. In a similar vein, an on-chain RFQ is another net new use case that will be coming to Ethereum through Eclipse. This is something that is only possible on a low latency, low fee environment, right? Because the environment needs to be low latency in order to make sure that no outdated quotes are getting accepted. Things need to be low fees because it requires a lot of frequent interactions, where it's just submission requests, delivery of quotes, so on and so forth. So this is a lot of things that can that's only possible really on Eclipse. A few others here. One that I'm really excited about is continuous prediction markets. Similar vein to kind of the previous ones, we need low latency for real-time updates. Another big aspect actually on a lot of these ideas is having frequent and cheap Oracle updates. So a lot of the Oracle updates are actually a blocker for a lot of DeFi protocols on other chains, just because of you can't get fast enough, you can't get real-time price feeds, or price feeds that are accurate enough to really carry out as concentrated liquidity as you would like, or changing your positions and whatnot. So this Oracle point is pretty significant. And of course, because it's going to be a low fee environment, you will enable lower scale bets in this predictions market. Next one is on-chain FX trading, so foreign exchange trading. If you're familiar with foreign exchange trading, you know that it's a very fast-paced environment. So again, the architecture needs to be extremely low latency. And of course, sufficient liquidity is a big thing for FX trading, so you got to tap into the Ethereum liquidity and get a benefit from that. And like I said earlier, the oracles for reliable price feeds is also another important factor on why the on-chain FX trading would be best suited for something like Eclipse. On to the more consumer side of things. Eclipse can enable a lot of novel NFT mechanisms because of several developments. One being the local fee market. So like I said earlier in the presentation, you get to avoid something that happened to Yuga Labs, where one hot mint basically congests the rest of the chain and makes it unusable, even if you're doing a DeFi transaction, right? So because you don't really have that constraint anymore on a multi-threaded environment, you're able to experiment a lot more with novel NFT minting mechanisms. An example of that is you can do something like a multi-Dutch auction, where instead of just bidding on the NFT in a regular Dutch auction, you can actually bid on any combination of traits and run simultaneous Dutch auctions based off of that, because the fees are so low and you don't really have to worry about congesting the rest of the chain. So I think we'll see a lot of new interesting mint mechanisms that come out of Eclipse. Two other reasons why Eclipse is well suited for NFTs. The first one being Token 2022. It basically enables you to mint, millions of NFTs for basically $100. It is orders of magnitude cheaper than minting on Ethereum or even any existing L2s. The last reason why Eclipse is well suited for NFTs is that there's going to be native enforcement of royalties. That's an issue that Solana has solved that Ethereum is still grappling with. Lastly, DePIN, so decentralized physical infrastructure networks. If you're unfamiliar, that's like a Helium or render that's currently on Solana right now. But essentially, you're able to share kind of large-scale infrastructure and break it down to individual service providers. And there are a lot of benefits to doing so. For example, 5G really is only enabled by something like DePIN because of, I won't bore you with the details, but it's a little bit different than having large cell towers. Instead, you need small cells in close proximity to each other. You can only achieve something like that when you have a large network of participants. So I think DePINs will be quite an interesting use case. And something that people don't think about when they think DePINs is DePINs need extremely low fees, because even if you think about it from a payments perspective, having 1 million wallets, 1 million service providers, and you have to reward 1 million wallets on chain at a regular cadence gets very expensive very quickly. Another reason why DePINs are well suited for Eclipse is that you can tap into Ethereum liquidity. The token is quite integral to any DePIN network or any DePIN. And having that liquidity for service providers to be able to trade and people to be able to pay for services in your token is really important. And of course, I didn't mention it here, but there are other consumer use cases like social or gaming. For gaming, you don't have to just have certain assets on chain and maybe just a couple NFTs or a token on chain, but instead every transaction or every user interaction can actually be a transaction on chain. Yeah, in summary, why build on Eclipse? I actually think from first principles, why wouldn't you build on Eclipse, right? Because first we have parallel execution, so you'll get significantly higher throughput than compared to any single-threaded EVM chain, and it's also the most production-ready, kind of battle-tested VM on the market today. Number two, you get to leverage Ethereum liquidity and user base. Again, that $47 billion of TVL is not something to be ignored, and I think it's really valuable as a developer choosing where to build an app. And lastly, ecosystem support. So we try to support our ecosystem in whatever ways we can, whether that's through ecosystem grants to top projects or providing marketing, engineering support. And of course, we have the ability to direct users to your protocol through incentives. So if you're interested in building on Eclipse, feel free to reach out. You can find us you can reach out to Neil at Eclipse Builders, team at Eclipse Builders. You can reach out to me on Twitter or X, whatever you call it, at 0xSydney. Thanks, everyone.